All right. Good day, everyone. My name is Paul Lorenzo. I will be walking you through the on how to approach and solve this kind of supply chain optimization problem for activity number one. Uh, this exercise. All right. Let's get started by understanding the scenario and the requirements. All right. So, number one, LC Consulting, a supply chain consulting firm, must decide on the location of its home offices. So its clients are located primarily in the 16 states listed in Table 5 of 5. So there are four potential sites for home offices: Los Angeles, Tulsa, Denver, and Seattle. The annual fixed cost of locating an office in Los Angeles is $165,428. In Tulsa, that is 131 and $230 on 1,000. Denver is 140,000 and Seattle is 145,000. So the expected number of each state and the travel costs from each potential site are shown in table 5 of 5. All right, so each consultant is expected to actually have 10, or as actually each consultant is expected to take no more than 25 trips per year. So there are 5 questions to answer this in this exercise. So let's begin by tackling each one. All right, so we have to understand the process first. So each consultant is expected to take at most 25 trips each year. If there are no restrictions on the number of consultants at the site, and the goal is to minimize costs, where should the home offices be located and how many consultants should be assigned to each office? What is the annual cost in terms of the facility and travel? If at most 10 consultants are to be assigned to a home office, where should the offices be set up? How many consultants should be assigned to each office? And what is the annual cost of this network? So what do you think of a rule by which all consulting projects out of a given state are assigned to one home office? And how much is this policy likely to add to cost compared to allowing multiple offices to handle a single state? All right, so this is my table that has already been pre-made while I was exploring around the project. So we have to understand the process first. As you can see here in this table, I already put in the states, total number of trips, the total trips from LA, the cost, the trips from Tulsa, cost from Tulsa, trips from Denver, cost from Denver, trips from Seattle, and then the cost. And then I also put in here the demand constraint of the following. All right, so that's to solve the problem, we have to actually calculate the total system cost using Excel solver tool. So we have to go through data and then just click on solver. So the data and then solver. And then as you can see here, we have to get the minimum, or at least our latest objective is to actually set the objective to minimize cost, right? So this is for minimize. And then we have to identify the decision variables. So these are the numbers of trips. Sorry. Also going back here. So these are the numbers of trips assigned from each office. Los Angeles, which is this one. Tulsa, let me just highlight. Close this for now. Sorry. All right. So that's trips from LA, trips from Tulsa, trips from Denver, and then trips from Seattle. So we have to set up the constraints. So the constraints, all trip variables should be integers and should be greater or not equal to, or equal to 0, as you can see here in the decision variables, and which is the constraints. So the demand constraint is the total number of trips required per state. So that should be exactly met. Now we just have to click solve to compute and let Excel do the work for us. So for example, if I have to go back there again and recompute this, just select here close. And then when I click solve, I would let Excel compute the optimal value. So once solved, we have to get the total system cost, which happens to be, in this case, $633.783. Just click on close here first. There you go, as you can see. Let me just reopen the file again. All right. So let me just open my file here. All right. So going back, so we're gonna see here the following. So this is the solver. That's the value as I get. This is the total system cost, which will be 633 and 783,000. And then how do we? Let me just delete this. These are just my notes. All right. So how do we calculate the demand constraint, or how does it work? So we calculated the demand constraint by summing off all the trips assigned from each office to a particular state and subtracting it from the total required trips to that state. So the result should be 0, just this one right here. And then um, moving forward, meaning the demand has been perfectly met. So this process is repeated for each of the 16 states to ensure the full coverage. Let's type in here my surname just to ensure of the credibility of the file. All right. So moving forward, how do we calculate the number of constraints? Uh, Once we know how many trips are assigned to each office, we have to sum up all the trips per office, and then divide that by the total of 25, the total of that by 25. Then since each consultant can take a maximum of 25 trips per year, we have to round up the result to get the number of consultants required per office. All right, so we got the number of rounding up. We got 5 consultants, the number of consultants from Seattle, 10 from Denver, 5 from Tulsa, and then 8 from LA. All right, so now how do we compute the cost? So the fixed cost of each office is taken directly from the given data. So to get the travel cost, we multiply the number of trips by cost per trip from the office. We have to sum these up for each office. And then right after, we have to add the fixed cost plus the travel cost to get the total cost per office. So you're gonna see here in my formula, we just sum up the entire cost from the LA together with from Tulsa, Denver, and then Seattle. All right, so moving forward, now we get to answer letter A. If there are no restrictions on the number of consultants at a site and the goal is to minimize cost, where should the home offices be located and how many consultants should be assigned to each office? So what is the annual cost in terms of the facility and travel? All right, so we use the solver to actually minimize the cost without limiting the number of consultants per office. So the optimal assignment gives us a total cost of, again, 633,783, and then the number of consultants per office, trips, and costs are all outlined and input in the table. There we go. All right. So letter B, if at most 10 consultants are to be assigned at a home office, where should be the offices set up? How many consultants should be assigned to each office? What is the annual cost of this network? All right. What do? We add a constraint in the solver, limiting consultants at each office to a maximum of 10. So our fixed cost should be around 140,000 from Denver. And then the travel cost will be around 459,625. And then the total is 596. All right, let's move forward. So letter C, assigning each state to only one office. So if each state is assigned to only one office, flexibility is lost. So the current optimized model distributes trips from multiple offices to the same state. So depending on cost and availability. So we have to enforce one office per state rule. So that increases the travel distances and may actually overload certain offices. So what can that lead to? That can actually lead to higher travel expenses, more consultants needed. We have to increase our operational cost. So it's estimated that the total cost could be increased by 10 to 20% or more under this rule, depending on the state assignments. So my final thoughts while I was performing this exercise is that it's actually crucial how strategic planning and optimization are in minimizing supply chain costs. So using tools like a simple Excel solver allow us to make data-driven decisions by balancing fixed and variable costs while respecting constraints like trip limits per consultant. So that's my takeaway, or at least my final thoughts. So I hope this breakdown gives you clarity on how to approach similar problems and help you build your confidence in solving optimization problems. And thank you so much for listening and have a good one.